The following simulation is an effect of the studies carried out with the purpose of sharing with the plumber technicians community the understanding of the calculation process on a simple water system graphically. It is a particular view and does not establish any reference to the canons and parameters and has been established by the scientific community. In the first step, we will find the entire fixture unit's volume for the system. Pay attention, in present notes, in the cells marked with numbers, footnote. In this area, we will introduce the number of the present fixture in the blueprint. Other important data that must be taken into account before proceeding to the next step. Total developed length equals 145 feet. Minimum pressure equals 75 pounds per square inch. Water closet 1.6 gravity tank. Single-story building. Here we have no data measurements concerning the length of the sections but assume that this is the longest water route. Most remote outlet follows path through water heater to hot water outlet. Do not forget that the parts of the water system, such as backflow preventers, softeners, water filters, will affect the total of the minimum available pressure, and therefore they must have them in mind as a part of the system. In Table 610.4 we locate the position of the pressure that we have, and the maximum length present to determine the diameter of the water meter, and the main supply line. Then according to the position of the pressure values, fixture units, and the maximum length we are located in 3/4 inch for the water meter, and 1 inch for main line. This will be the part of the table that we will focus our work on. And more specifically, this will be the area where we will do our calculations. We already know the value of fixture units that corresponds to water heater, total the hot water fixture units. We also know the value of fixture units that corresponds to each fixture, so we will mark them in each position in the blueprint, Table 610.3. Remember that the hose bit valves count in different ways, in values. When we perform the total count of fixture units, the first valve value is 2.5, but after the first valve, the value of the next ones will be 1.0. However, on the blueprint the value 1.0 of each hose bit valve will retreat back to the value 2.5 fixture unit. Now we mark the sums of the fixtures at the points where the various branches converge between them. For example, 1.5 plus 2.5 is equal to 4.0. Why here, in this position we have obtained the result of 22.0 fixture units, but the sum should be 23.5. This hose bib. For this point in the system, it will count like 1.0 fixture units. Let's mark the value of hot water. Let's finish marking the fixture unit's value of cold water, and its remaining positions. Here, the total value of fixture units on hot water equals to the total value of fixture units on cold water. This hose bib. For this point in the system, it will count like 1.0 fixture units. And now, the last part of the calculation, pipe size, with the table 610.4. Here fixture unit value in excess of originally established demand for building. This inflated value is the result of adding the hot water fixture unit demand back into the cold water demand serving the water heater. Section 610.9 states, no branch piping is required to be larger in size than that required by Table 610.4 for the building supply pipe.